Welcome to Olympiad.
Let's explore a fascinating geometric proof of mean inequalities. Suppose we have two real numbers a and b with a greater than or equal to b greater than or equal to 0. Starting with the line segment of length a, overlay on it another line segment of length b. Now take half of the uncovered part, that is a minus b by 2, and use it as the radius to draw a circle. From the center of the circle, connect the far end of the line segment. The yellow line has a length a plus b by 2, which is the arithmetic mean. Next, draw a perpendicular radius, and by Pythagorean theorem, the hypotenuse can be calculated, and the calculation will be as follows. First, the hypotenuse will be equal to square root of a plus b by 2 whole square plus a minus b by 2 whole square, which upon solving will come out to be equal to a square plus b square divided by 2, and this is nothing but the root mean square. Now draw a tangent from the extended endpoint. The triangle thus formed will give us the side length, that will be equal to root AB, and that can also be calculated with the help of the Pythagorean theorem. Now this root AB is nothing but the geometric mean. Now dropping a perpendicular from the point of tangency will create a similar triangles, and the two shaded triangles will be similar as have a 90-degree and an angle in common. Now with the condition of similarity, we can find the smaller leg, and the smaller leg will come out to be equal to 2AB divided by a plus b. Now looking very carefully over here and working backwards, we get the inequality chain as 2ab divided by a plus b is less than or equal to root ab is less than or equal to a plus b by 2 and is less than or equal to square root of a square plus b square divided by 2. So which gives us the famous mean inequality, that is the harmonic mean is going to be less than or equal to geometric mean is going to be less than equal to arithmetic mean and is going to be less than equal to root mean square. And the equality holds only when a is equal to v, where the entire construction collapses into a single line. Isn't it beautiful how geometry brings the algebra to life? If you enjoyed this visualization, don't forget to like, share and subscribe for more maths explained visually.